Okay, welcome to Society of Amateur Radio Astronomer Drake's Lounge. This is our monthly meeting we have. We On this one we mostly discuss technical, but if you have observations, please show them. Today we have a group from Philippines that are going to show some of their radio astronomy work, and we'll go first with Jason, who's doing real time measurements of the sun using TED software. So, Jason, go ahead.
Okay. Hi, I'm Jason. So I'm going to share my screen and then I'll dive into it a little bit. So let's see, I am actually doing a sun test of my new dish, and it's in progress now. I mean, I just passed local noon and it's looking pretty good. So I did set up and I did some preliminary feed adjustment to maximize the output, and then set it up to transit at local noon. And I'm just doing a total power scan, mostly to test my beam of my antenna, and it's looking pretty dang good now. My early tests a few days ago were not nearly as good because I didn't have it adjusted yet. So just to give you an idea of what I'm doing as far as my dish is concerned. So here, can everybody see my screen, by the way?
Yes.
Okay. So, okay, why? Oh, this is just taking a minute to come up. Okay. So, let me put this down here. So this is generated from a tool that I built in Excel, but I just wrote it down in my notebook when I was actually doing the laying out of the profile. I basically have designed myself over the last couple years. I've designed a portable dish that's like a giant umbrella, and it uses plywood ribs to give me the parabolic profile, and then there's a sliding ring in the center on three vertical poles that are suspended from a very solid base, and I'll show you that in a minute. But this is the XY coordinates of the parabolic profile that I then lay out by hand with a with a with a yardstick and a pencil and sketch it out on the plywood. So let me see if I can. These aren't in the proper order here, but let's see if I got. Yeah, okay. So each of those ribs were laid out on a single piece of plywood. And then I cut them out, and they actually the I can only fit a 2 foot by 4 foot piece of plywood in the back seat of my car. So basically, I bought 2 foot by 4 foot pieces, and just made the ribs in two sections, and then basically just they're spliced together. There's a 2 inch overlap, and then I built the base and the sliding ring. So there's all the parts kind of cut out. I used a smaller diameter pipe for my connecting pieces than I did on my other, and I also used lighter duty materials to try to make the whole thing a little bit lighter duty, and it's also a lot more structurally sound. There were a lot of lessons learned from the original. So this was the initial when I first got it kind of set up, and it's still not tightened and smoothed yet. That took a process of a few days of messing with it, but actually today I finally have it adjusted. And then I also did I used some weatherproofing material to try to make it a little more weatherproof. I mean, obviously I still don't, it's portable, so I don't leave it out in the weather, but it does get exposed to moisture, even just from dew or light rain. And so lesson learned from my original dish, you know, that does deteriorate it over time, which is not surprising. This stuff seems to work pretty well. I've got about 3 coats on it, and it just seems to be handling it well. This is what I use for my cover material. Most of you have probably seen this before with my previous iteration of this. But yeah, this stuff's great. And Alex Pettit is the one that turned me on to this stuff, and it works really well. This was an earlier sun scan, and you can see some on-off power peaks here where I'm making adjustments to the position of the feed and stuff. This was a few days ago before I got it totally refined, but it still performed decently well. But now I'm actually in the middle of let me see if I can move this up here. Yeah. So now I'm actually in the middle of a transit scan, and this is what it's looking like now. So that's looking very, very nice. So I'm pleased. And I should get an accurate half power beam width reading of it out of this, and that should give me an idea of how it's going to perform. And then if all goes well, I'm planning to do a transit scan this early morning tomorrow of M31 and see if I can capture M31 again using this dish. And like I said, at the end of the day, I want to be able to bring this to the Eastern Conference next year and actually demonstrate extragalactic hydrogen observations live, or at least you know, at the conference. The objects might be passing over in the middle of the night or something, so I might be gathering data and then analyzing it during the day and then giving an update. So, but anyway, that's kind of what I got going on. Anybody have any comments, questions? I'm gonna go ahead and stop sharing my screen now.
Actually, Jason, if you could keep sharing.
Okay.
I had a quick question for you. You had made a statement when you started that things were looking good because yesterday it wasn't looking good. Well, what's telling you in your screenshot there? What's telling you that things are looking good versus what was looking bad yesterday?
Well, so you can see it's a lot smoother. The profile's a lot smoother in the one going live. I'm assuming you can see my screen again.
Yes,
So
we
this
can.
is a nice smooth curve. The other thing is I was realizing, so let me see if I've got, let me pull up these photos again and I'll flip through them and get to, yeah, so it was a little noisier, but also what I noticed is that my when I took measurements today, I brought it in the house and set it up in my room where I have a nice flat concrete floor. I have a basement room, and I was doing measurements of the height of the profile to make sure it's actually open to the proper amount, and it did need to be adjusted. I needed to open it a little wider, and part of it is as I tighten up the fabric over the frame, it kind of pulls it up and closes it a little bit more than it was to start with. And so after I got the final tightening of the fabric, then I had to actually slide the ring down about 3 inches farther down to open it and tighten it really well. And now it's you know, basically if you look at my, where is it, my profile measurements, the y coordinate is the vertical height above the vertex of the parabola. And so I can take that value where 52 inches is the outer edge of the dish, and I can it's supposed to be 23 point, just a little over 23 inches above the vertex vertically. And so then I can measure that from the floor, accounting for the feet and the base and the thickness of the rib itself, and figure out, okay, how high is it supposed to be? When it's all the way open, it should be matching that value. And so now I've got it a lot closer to where it's supposed to be. I guess, does that answer your question?
Yeah, it does. I appreciate it. Just wanted a little bit more insight into, you were looking at the data rolling across and just said this looks so much better than yesterday, and I was just wondering what was standing out to you.
So if you look at this sun scan, look how uneven it is. I mean, this is just because the cover wasn't fully tightened yet, and it wasn't as smooth as it could be. So I had, defects in the symmetry of the surface and stuff, and those were showing up in the profile itself. And now, as you can see, when we look at the live scan that's still underway today, I mean, it's beautiful. It's like perfectly symmetrical, perfectly smooth. It's looking exactly as it should. So,
and you're speaking of the strip charts over on the right side there.
yes,
Bring that up again.
Yeah.
I do see that you're using 1420.406, one of the top numbers up there on the right. You may want to stay away from hydrogen if you're actually doing a sun scan, because you really have two transmitters up in the sky then, the hydrogen.
That is true.
There is a way in AZ Call that you can change that frequency, and just for others, that's helpful.
Yeah, Thanks. I didn't really think about that because it hasn't ever been enough of a factor to change it much. But you're right. If I offset it to maybe like 23, like 1423, it would be well out of band and it would be fine. Which I already do that when I'm doing when I'm capturing reference scans out of band, which is what I often do when I'm just doing a Milky Way drift scan. So yeah. All right. I'm going to go ahead and stop sharing so others can.
All right. Thanks a lot, Jason.
Yep.
Great work.
Thanks.
And okay, we have a special presentation by Celsius. They're in the Philippines, and his team. Celsius, introduce yourself. Tell us where you're from and who your team is.
Hello, everyone. Am I audible?
Go ahead.
Yeah,
Yes,
we can hear you.
Yes, we hear you.
Thank you. Let me share my screen. Do you see my screen now?
Yes.
All right. So, good day, everyone. I am Sergio Celso, and I'm with Laris Guevara and Robert Serrano, and also with our mentor, instructor Gian Santos, and we are from the Philippines. Specifically, we are from Rizal Technological University, a state university in the National Capital Region. So we're here to present our research paper as part of the requirements of astronomical research immersion 2. But before we start, we will introduce the development of astronomy in the Philippines. So the astronomy in the Philippines started when the Jesuit scientists established the Manila Observatory in 1865. This observatory engaged in weather observations and forecasting, and later on astronomy and geomagnetism, time telling, and seismology. It was evolved into a weather bureau during American colonization era. And at present, it is now the Philippine Atmospheric, Geophysical, and Astronomical Services Administration or PAGASA under the Philippine Department of Science and Technology.
Okay. So good day, everyone. So I am Roberto Cristiano III. And so to continue, on August 8, 2019, the former President Rodrigo R. Duterte signed the Republic Act 11363 establishing the Philippine Space Agency or PhilSA in the Philippines. And in 2016, the Philippines deployed its first microsatellite named Diwata 1, which means nature spirit, and followed by its nanosatellite, which is the Maya 1, which means a native bird in the Philippines. And in 2025, the PhilSA is planning or targeting to launch the first satellite of the country named MULA, which means Multispectral Unit for Land Assessment.
To continue, let me first introduce myself. I am Laris Guevara, and let me introduce to you the astronomy education in the Philippines. So, in 2005, Rizal Technological University, where we are from, offered the very first formal degree program of Master of Science in Astronomy. And in 2007, it opened its undergraduate program in astronomy technology. The Center for Astronomy Research and Development is established in 2019. It became a hub for astronomy research and development with several laboratories on light pollution, astronomical observation and instrumentation, astrophysics, astronomy for the public, space weather, and space technology. So when RTU started, actually, um, only a few people knows or is knowledgeable about astronomy. So they only have when they started, they only have a few students. But as years goes by, like now currently, RTU already has more than hundred students, like maybe 500 students or like 1,000 students already. And also, there are actually a lot of students that already graduated from astronomy with Latin honors. And it also, astronomy is already being known to the public and is already recognized by the public. Thank you.
So now we will begin our presentation, our paper presentation, and the title of our research is Acquisition of Automatic Picture Transmission of NOAA 18 and NOAA 19 using V-dipole antenna for the Philippine Archipelago cloud cover monitoring. And we are grateful uh, to the Society of Amateur Radio Astronomers for the opportunity to present. So the outline of our presentation is first the introduction, methodology, and the results and analysis with three parts, namely V-dipole antenna analysis, frequency offset, and acquisition results. And then we will wrap up our paper with the conclusion.
So let me start the introduction. So we use NOAA satellites as our research interest because it is an analog image transmission system called um, automatic picture transmission that enables us any surface station to access the weather satellite image data, the passing of the weather satellites from the north to the south pole and cross the equator from for about 14 times every day above the user station enables to provide weather data such as for the cloud covering, which is our research interest. Next slide, please. So as you can see, as I have said, NOAA satellites are weather satellites. That's why we used it, because it actually crosses our country twice every day. That's why we were able to obtain data. That's why we also choose the NOAA satellites as our research interest. Next slide, please. Thank you. So NOAA satellites carries advanced, very high resolution radiometer for multipurpose imagery and Earth observation. It enables us to capture cloud covering across Philippine archipelago, and it measures the cloud optical depth, top height, and temperature. Lift area index, normalized difference vegetation index, sea surface temperature, and ice cover. So because of this property, that the NOAA satellite can produce a high resolution results and data that can also be received by any surface station. So that is actually the reason why we use the linear polarized antenna to produce a good signal reception, because the APT signal produced by NOAA satellites are right-handedly circular polarized. So our antenna are linearly polarized antenna. That's the reason. It's actually the reason why we use the linearly polarized antenna is because the NOAA satellites are right-handed circularly polarized. Next slide, please. So our research focuses on hardware and software execution, highlighting the antenna to receive and decode the APT signal from NOAA 18 and NOAA 19 weather satellites for the cloud cover monitoring of the Philippine archipelago. The live weather images and data that are produced from those satellites can be used to assess the current cloud cover of the Philippine archipelago, which can also be used to evaluate the different weather and climate in different localities of the respective country. So the methodology will be presented by Mr. Robert Serrano. Thank you.
Okay, let's now proceed to the methodology. So, for the methodology, we will be presenting figures and images to show you the procedures on how we set up and program our antenna. Okay, so the first is a pictorial scheme for the data acquisition of the satellite images. So, the APT, or the image transmission from the NOAA 18 and NOAA 19 satellite, will then be received by the V-dipole antenna, which is then connected to our 75 ohms coaxial cable that is attached to the RTL SDR together with a low noise amplifier to improve the resolution of the image transmission collected. Okay, so both the RTL and the RTL SDR and the LNA is connected through a female to female connector that is connected to the computer, which have a software for tracking the NOAA 18 and NOAA 19 satellites and decoding the automatic picture transmissions, or the APT, received and transmitted by the RTL SDR. Okay, so next slide, please. Okay, so the next one is the block diagram, which presents the whole process of how the data had been acquired. So it starts with the V-dipole antenna receiving automatic picture transmission signals from NOAA satellites, and which are then sent to a coaxial cable to a low noise amplifier, or LNA, and the LNA boosts and amplifies the APT signals, providing a substantial power gain. This amplified signal is transmitted by the RTL SDR device, which sends a decoded signal to a computer running the SDR++ software. So all of this happens while we track the satellite real-time with the use of GPredict, which is a real-time satellite tracking software. So the SDR++ records receive APT signal, which is subsequently decoded by the SatDump, and which is a satellite data processing software which was used to apply various filters overlays and enhancements such as color and infrared thermal enhancements for better analysis of the image transmitted. Okay, so next slide, please. Okay, so next figure will be the pictorial diagram of the B-dipole antenna itself. So the B-dipole antenna is a suitable antenna for receiving circularly polarized radio waves at 137 MHz. So the design of the antenna was inspired and tested by ADAM 9A4QV, and as you can see, the legs is 53.4 centimeters long, with the aluminum rods being 3 millimeters in diameter. And these rods are then attached to the choke block terminals, which is then connected to the coaxial cables. The aluminum rods have an angle of separation of about 120 degrees, which is aligned in a horizontal direction to have a minimum interference when it comes to terrestrial signal. And its vertical polarization is at 20 decibels. So the antenna also faces either north or south, which is the direction of passing of the NOAA-18 and NOAA-19 satellites. Okay, so the remaining figures we will show you the actual picture of our setup of the antenna and how it and the actual procedures. So next slide, please. Okay, so the next figure shown is the B-dipole antenna, which is mounted to a telescopic tripod. So the telescopic tripod was used as a suitable mount due to its conveniency when it comes to adjusting the height of the antenna for better signal receptions. So as you can see, the antenna is placed horizontally to a flat wood, and it is connected to the 75 ohms coaxial cable, which was used due to its low loss characteristics and good impedance match. Okay, so next slide, please. Okay, so the next figure shows the connection from the coaxial cable to the low noise amplifier, which is connected to the RTL SDR via female-to-female connector. So the LNA serves as an amplifier for the received APT for the transmission of the RTL SDR to have a better reception. And actually, there is a mistake in our part here. So if you would notice, the female-to-female connector is a bit lengthy, if you would say, since the female connector is attached to a female connector, which is then attached to a female-to-female connector, which is also attached to a female and a male connector. So it's a bit lengthy, and we could definitely shorten the connection and improve it in the next studies. Yeah, so next slide, please. Okay, so the next figure shows the overall process of the acquisition. So in the left side, you will see our tracking software, which is the GPredict, which we use to track the orbit and passing of NOAA-18 and NOAA-19 satellites real time. So the GPredict tracks the azimuth, elevation, slant range, the next event, the location, the footprint, altitude, velocity, and even the Doppler shift of the satellites real time. So along with the tracking of the satellite, on the background, you can see another software that we use, which is the SDR++. So we use this software to receive, analyze, and process the APT signals that we receive from the NOAA-18 and the NOAA-19 satellite. So as you can see in the background, the offset tuning, automatic gain control or ACG, and the IQ correction is selected in order to automatically adjust the gain of the incoming signal and to correct the imperfections such as the sudden frequency shift, or even the inaccuracies. And we also adjusted the SDR into NFM or narrow frequency modulation, which is best for spectrum usage and data receiving purposes. So the GPredict shows the NOAA-19 to be almost overhead or almost zenith of our location. And we simultaneously collect its APT signals through SDR++ with the selected bandwidth to be approximately 137.08 to 137.12 MHz. And the peaks show the APT signals from the NOAA-19, which was then recorded, processed, and enhanced in the SatDump software. Okay, so that would be all for the methodology. So Mr. Celso will now discuss the results and analysis. Thank you.
Hey, again, good day, everyone. So we have a three-part three parts of the results and discussion. And the first in our agenda would be the V-dipole antenna analysis. So the measurements are based on the calculations of M-MANA-GAL software, an antenna analyzing tool. The analysis of the software is focused on the working frequency of NOAA 18 and NOAA 19, which is simulated in a free space with varying heights of 0.5 meter, 1 meter, 2 meter, 4 meters, 8 meters, and 16 meters that are set as parameters for both frequency. So in the picture, we have the geometric view of our V-dipole antenna design in the M-MANA GAL antenna analyzing tool. So the significance of antenna height is shown in the next two tables as it affects the reception of the APT signal. Therefore, to maximize the antenna gain, the height should be adjusted accordingly with the projected elevation of a particular satellite path. And in this table, we have the measurement results of our V-dipole antenna of NOAA 18 in frequency of 137.9125 megahertz. And the results are from our ohms to the F over B dB with, of course, varying height from 0.5 meter up to 16 meters. Okay, next slide, please. Okay, so the same with NOAA 19, we have also the results coming from, again, to our antenna analyzing tool. And the results showed from our ohms up until F over B dB. And also the varying height from 0.5 meter to 16 meters. So now we have the horizontal and vertical far field plots of first the NOAA 18 with 137.9125 megahertz in different heights from 0.5 up until 16 meters. And of course, we have also the far field plots in horizontal and vertical of NOAA 19 with 137.1 megahertz, and also different heights from 0.5 meter until 16 meters. So the second agenda for our results and discussion is the frequency offset observed during the project. The frequency offset is the slight shift of radio frequency due to the mismatch in the transmitter, receiver oscillators, and of course the Doppler effect as the transmitter, just like the satellites, is moving. The RTL SDR had a low quality crystal oscillator of positive negative 150 parts per million offset, equating to around 20.687 kilohertz frequencies offset. The NOAA 19 satellite with a working frequency of 137.1 megahertz should have 137.09 megahertz of cause signal reception. And the NOAA 18 with a working frequency of 137.9125 megahertz should have 137.89892 megahertz of cause signal reception. The offset frequency on NOAA 18 and NOAA 19 and the value of that frequency offset of 20.687 is caused by the RTL SDR's low quality crystal oscillator, and of course by the environmental factors, specifically the temperature. So for our last agenda is the acquisition results in our results and discussion. So we have the NOAA 18 path with elapsed time and the channel A and channel B of NOAA 18. The path of NOAA 18 in its path at 4 degrees 33 minutes of north and 121 degrees 06 minutes east 10:52 a.m. PHT on May 22, 2024 started from the north with an initial azimuth of 11.76 degrees, traversing the horizon with a maximum elevation of about 88 degrees, just off the zenith on the western horizon, and ending to the south with an azimuth of 194.22 degrees. The recording duration lasted 8 minutes and 45 seconds, while the pass lasts for approximately 13 minutes. The antenna height that we use in receiving the NOAA 18 APT in this pass was 0.5 meters to take advantage of the high elevation pass of the satellite. We have also here the NOAA 18 channel A and channel B, which is channel A is for visible light, whereas channel B is for infrared. We have also here the NOAA 19 path with elapsed time in minutes and seconds, and also the NOAA 19 channel A and channel B. The path of NOAA 19 in its path at again for degrees 33 minutes north, 121 degrees 6 minutes east at 9:11 a.m. PHST on May 23, 2024. Started from the north with an initial azimuth of 12.57 degrees, traversing the horizon with a maximum elevation of around 89 degrees on the eastern horizon and ending to the south with an azimuth of 193.24 degrees. The recording duration lasts for about 8 minutes and 35 seconds, while the pass lasts again, just like NOAA 18, for about 15 minutes. The antenna height that was used in this pass was also 0.5 meters, the same as NOAA 18, to take advantage again of the high elevation pass of the satellite. These channels, channel A and channel B of NOAA 19 and NOAA 18, were produced by the 2,400 Hz pixel values embedded in the audio file received by the antenna. The Advanced Very High Resolution Radiometer, or AVHRR3, used by NOAA satellites is a very wide field of view spaceborne sensor with the spatial resolution of 4 kilometers, producing maps with 1:8,000 scale. It is corrected for a nearly constant geometric resolution to free the image of distortion due to the curvature of the Earth. Process channels A and B produce different RGB composite imagery to highlight the presence of meteorological phenomena, specifically cloud covering. Next slide. The MCIR composite enhances the clouds in the composites, it appearing as white and progressively less transparent as the cloud thickens, preserving more cloud data. Next slide. The MCIR rain composite shows the likelihood of precipitation appearing green, yellow, red, and black. Now the conclusion again will present by Mr. Robert Serra.
Okay, so furthermore, to conclude our paper, our study, the inexpensive B-dipole antenna that we use, that is tuned in 137 MHz, was able to receive APT signals from the satellite along an established relationship or correlation between the height of the antenna and the maximum elevation of the satellite pass to maximize the gain. The frequency offset was also identified to be 20.687 kHz, shifting the frequency of NOAA 18 to 137.892 MHz and the NOAA 19 to 137.079 MHz. So the data transmitter from the APT signal was processed and decoded by the SATCOM and was able to produce visible infrared channels as well as other RGB composite imageries. like the multi-channel infrared composite and the multi-channel infrared rain composite for cloud cover monitoring. So next slide, please.
Boy, sa reference,
Okay, next slide, please. Okay, so these are all the references that we use in order to gather substantial proof, evidence, and data for our paper. Okay, so next slide, please. Okay, so if ever you have any concerns or questions, these are all our emails. Again, that will be all for our presentation. We are now open for any questions and queries. Thank you. That's all.
Well, excellent work. Anybody have any Anybody have any questions?
Yeah, I was. Oh, whoops.
Just a quickie. How does the quality of the video compare to what you would find from a maybe like a commercial site, commercial equipment? Did you understand my question?
Hello. Will you repeat the question?
How does the quality of your received video images compare to what you might find with commercial equipment?
So the quality of our received video or the video that we have, we may say that it is close enough to the commercially videos. But then again, we use inexpensive materials and DIY products in order to build this setup of antenna. The reason for that is the limitations in our financial assistance and also the limitations in the materials available in our country and also the materials that we have bought. So if an example of this is the RTL SDR that we use. So the RTL SDR that we use is just an imitation of the original product as well as the LNA that we use. But then again, we could improve this furthermore in the future.
Thank you.
Yeah, I was curious. Does your LNA have to have? Does it have a bandpass filter, or is it just wideband?
I think it's just a white band because our LNA is a basic one, no? A basic one. And to tell you honestly, here in the Philippines, we don't have we don't have access in the resources that you have in the US, like the no Olexo bird. We don't have here. We don't have that here in the Philippines. So we're really filling in the gap, the resource that we have here in the Philippines. So again, if we have a good filter, to amplify the signal more from the NOAA, I think that the quality of the data, the pictures that we have would be more good. Thank you.
Yeah, it appears like you still had a pretty decent signal even without a filter, just because the signal from those satellites must be fairly strong signals. So that's good.
Yeah, and also to add on that, the frequency offset of that was stated there was actually the frequency offset of the RTL SDR itself. So we did not consider the other factors such as the temperature in our country and other factors, since we cannot measure the frequency offset in a way, since we don't have the device capable of measuring such that. So what we use is that we use the actual page where the RTL SDR information is, and it is stated there that it has a 20.687 kilohertz of frequency offset, and that's the overall offset that we use for our paper. But then again, if ever that we could consider the other factors, the signal and the reception would even be better. Yes.
Any more questions?
Yeah, hi, it's Andrew Thornett here from England. I think it was fantastic and very encouraging. Thank you, guys. In fact, you've stimulated me to think I'll have a go. I've heard of people doing this, but never done it myself. I've got a spare RTL blog receiver hanging around somewhere, so I just need to decide what's going to be the best aerial and what I'm going to do for a band cutoff filter, and then hopefully I can repeat your results.
Excellent work. Thanks for the presentation.
Thank you.
Thank you so much.
Thank you so much.
Thank you.
everyone.
Thank you.
Again, if ever you have any concerns, these are all our emails. And that's all. Thank you. Thank you again.
Okay, and all of you are invited to any of our SARA Zoom sessions. We have 3 a month, and
Okay.
I think the this Friday is Drake's Lounge Australia, which is closer to your time zone, I believe, and
Yeah.
so that might be fun too. All right, well, keep in touch and feel free to listen in on all this and the rest of it. You'll find that what you were doing there, we have a lot of presentations that people are trying to do what you were doing, except not with satellites, but with astronomical objects. So it's very close. You guys are doing very close to what we do all the time with radio astronomy. So good work. Okay, well, let's move on. Did anybody else have a presentation they wanted to do?
Nick, Rich, I've got the results of my latest analysis of my Milky Way mapping exercise.
Okay, Andrew, go ahead.
I wouldn't say it's particularly insightful, but it might be inspirational. So the folks that know me here will know I started this radio astronomy lark about October last year, and with a great deal of help from people off this group, have progressed greatly. And one of the things that I am particularly enamored with is Ted Klein's Easy Radio Astronomy suite, because basically it allows idiots like myself to do amazing things without understanding what they are doing. Although the results I'm just about to present now show you do get into a bit of a difficulty when you don't know what it is you're looking at. And hopefully Ted's going to help me out at the end of this meeting with a little bit of a sort of subsidiary meeting. So if anybody's interested in finding out what the graphs mean that come out of Easy Radio Astronomy, Ted and I are staying on the line afterwards, and he's going to tell me, and you can learn at the same time. So what I'm going to do is just pull up my latest data. So I started off with a mapping exercise of the Milky Way at 1420.405 megahertz. That's hydrogen, using an 86 centimeter antenna in my back garden, which is in a suburban area in England, in the middle of England.
I don't think I see any sharing yet.
No, I haven't got that far. I'm just trying to pull it up. But that was last year. I did that by every 2 days, changing the elevation. But the new exercise, which has been going now for the last 6 months, so it's the first sort of half of what will be a year-long project to actually do a week at a time in each elevation point. And I shall explain what I mean by that in a second if I can find my results. Where have they gone? Right, okay, let's share this. Somebody remind me where the share option is.
Should be on the bottom.
Participants chat, react. Oh, share. Here we are. Yeah. Sorry, guys. So, firstly, you'll notice what I mean when I say about excessive production of graphs. They're probably not excessive if you understand what they are. So here are the graphs that got churned out of the system earlier today for me. Keep going, keep going, keep going, keep going. Ah, we finished about there now. So, so say this is using an 86 centimeter antenna, a really weird one, which is an ex-military dipole array in what's called Band C in Europe, which is.
Hey, Andrew, we're seeing all of your files, not just one picture.
Yeah, at the moment I haven't pulled one up yet. I'm just.
Oh, okay, sorry.
That's what you meant to see. So I'm just saying it was. It's produced for this area, which is 86 by 86 centimeters square. So it's composed of 16 little dipoles, all at about the right frequency for hydrogen, we've had various discussions on this group before about how good this is or isn't, but it performs at about the same at the end of the day as you would expect from an 86 centimeter dish. It's worth saying it's not really any better or any worse, which is good because these particular ex-military arrays are incredibly difficult to get hold of. So if it was a lot better, then I wouldn't be offering something that was practical for people to get. So pretty much any 86 centimeter device for picking up hydrogen signals would do the trick as well as I am today. It then does have a NUELEC Sawbird in the way to actually cut the frequency down to the hydrogen area, and then goes in through a receiver. I forget what I'm using, but it's something like an RTL block into the computer where easy radio astronomy does its magic. So I'm going to pull up this latest map that it's produced this time. This is on 550,000 individual data points. Is that appearing as one graph, or still just seeing a million of them?
We still see the file manager.
Okay, hang on. Let me change it. There we are. Can you see it now?
Now we see a pretty graph. Yeah, with the sun in the middle.
So Ted would explain it better than me, but basically the yellow point in the middle is sort of sun or us, for this sort of scale, it doesn't matter. And the green dot is the center of the Milky Way. What I always find, I'm a family doctor, medical doctor, and we all know of things like CT scans. And one of the things that CT scans can do and MRI scans can do that a standard X-ray doesn't is it can give you a view from a different perspective. So a normal X-ray, you're sort of looking front to back or side to side. But what you can do with a CT scan is you can take your pictures front to back or side to side and then combine them again so that you get a different perspective and look at it from the top downwards, even though your receiver or your radiation emitter wasn't located at those locations. And this is exactly what easy radio astronomy does here, which completely blows my mind. We're located at the yellow spot, and yet the picture in front of you today is taken as if we were outside the Milky Way galaxy looking down. And for those folks in the Philippines, this is really very easy to set up. It is absolutely surprising how ridiculously easy it is to set up, especially with Ted Klein's easy radio astronomy, which is, of course, free, like most great things in radio astronomy, with fantastic support from Ted himself. He's always there to help people out. And I'm happy as a newbie if I can be of any help as well to people. And if you look at this map here, you can see that the data that comes tends to be within the 90-degree quadrant where we're located. It's difficult because of the location of the sun and the rest of the galaxy in relation to our sun to pick up stuff outside of that very much. So we get this like 0 to 90 degrees. And behind it, if you look, so you've got the nice big bright yellow line. And then if you go to the left, you can start to see a red line, which is coming out there. A lot fainter, but that is the galactic arm that's behind the galactic arm. Again, no matter how good your astrophotography gear is, you aim it up at the sky, you only get the front to back view, and it's very difficult to tell what's behind the image in front of you, because the image in front of you obscures the stuff behind it. But here, with this magical view of looking from outside, sort of a coronal view from looking outside the Milky Way galaxy, we can actually see the second arm behind the first. And the color there, the yellow and the red, gives us information in terms of Doppler shift. So it's telling us how fast this stuff is moving as well. So potentially there's an enormous amount of data and analysis that can be taken out of that to predict it, which is where the rest of easy radio astronomy's graphs start to come in. So if we go back to them and see if I can find something a little bit interesting. As I say, my particular problem is I don't really understand it that well. So, but maybe I can pick up a few that I find particularly interesting. Right. So has the graph changed on the screen to this? It's one with a blob in the middle.
Yes.
Yeah. So Ted, you please correct me if I've got this wrong. So this is a section like an up-down section through a cake, isn't it?
Not exactly. This shows velocity up and down, increasing up, and depending where you're looking in the galaxy, we can see galactic longitude increasing to the left on the bottom there. So this is just a frequency scan. This is what you have to work with, and later on it tries to plot that in different ways.
Right. So if I change the graph there.
I'm sorry, this was latitude on the bottom, pardon me. And so this is kind of scanning up and down through the plane of the galaxy. And you can understand the middle part is where all the action was. That's why it was kind of thick. It is made up of a lot of these things, all lined up like books on a shelf.
Yes, so just pull that back. So we get a lot of individual graphs showing different parts of the galaxy there, don't we? Which show that. I go back. And these ones here, Ted, what ones are these showing?
Because this is made by the GLON, Galactic Longitude Program, GLON, this is looking with the galaxy along the horizontal white line. That's the plane of the galaxy. And you are looking above the galaxy from the sun in the middle. And you're seeing things up high and down low. There seemed to be something up higher up in there. So you are doing a cross section through a particular galactic longitude of the galaxy to look at the 3D shape of it.
And again, you can then check. Oh, sorry. You can then change that and move. So these two different longitudes, are they?
I'm trying to remember. Yeah, I see the number topped at the top. It says 55, 50, 45. Those are the different galactic longitudes. The P on the front means it's a positive galactic longitude. And so you're doing different cross sections, kind of facing the galactic center and turning to the left a little bit more through the galactic plane.
Right. So I don't want to go through everything. That's just to give folks a little bit of a taste of what's here. As you can see, I've got an awful lot to learn myself about what this stuff means, but it is quite mind-blowing, these different perspectives that the software produces to give you views of the galaxy, not just in terms of how those arms spread out from us, sort of outwards from us, or out from the middle of the Milky Way, but also we can see up and down from that, above and below the plane of the galaxy, and we can what we're seeing as well is the velocity changes that are there as well. Again, there is no such thing in astrophotography that can give that sort of information to you. And if there's somebody here on this group today that has never done this, I can strongly encourage that you give it a go. It's so easy to do. And if it works in my house, it works in a very radio polluted location. So it should work where you are. And it doesn't take up much space. And I will come back in another few months once it's all completed and show you the final map. Thanks very much.
Okay, any questions for Andrew? All right. Ted, you got any follow-up you want to present?
No, I'm still recovering from the wonderful conference we had. That was exciting, and I'm working on an all-sky camera right behind my head up on this observatory.
All right.
Okay, I have a small presentation. I've got my horn built, and I have 3 or 4 slides I'd like to show you.
Go ahead, Chet.
Okay, let me share my screen here.
We see it.
Okay. All right, so here's my horn. I live in a small house with a very small yard with 2 very big trees in it. So I have a very poor view of the sky from my house. But about 3 blocks from our house, there's a middle school, and I go to their parking lot to do my observations. That's been a nice experience. And I also go to one of the city parks to do it too. This is the Despira telescope that they designed for high school teachers. It has a sawbird tube for the LNA, and then something that has kind of been a headache for me. I'm using an AirSpy R2 for the SDR, and I'll say a little bit more about that in a minute. Okay, so here's my first light. This was at the city park. This is toward the constellation Puppis. And one of the things that I've learned the most from doing this is coming to understand the process of calibration much better than I did before. So this is looking in the direction of Puppis. And then this is a few days later when I had good calibration. The thing that I had to learn about calibration is that the procedure involves pointing the horn straight up for the cold calibration and then at the ground for the warm calibration. And I was treating my telescope as if it were a digital camera. So I would point it up, leave it pointing up for 10 or 15 seconds, and then point it to the ground and leave it 10 or 15 seconds. And what I have finally realized is that my tiny little antenna actually heats up and cools down quite a lot when it's pointed at different parts of the sky, and you need to give it time to kind of settle into a steady state. So now when I do the calibration, I point it at the sky for 10 minutes and then at the ground for 10 minutes. And that seems to work really well. So, so this is in the direction of Puppis. This is in the direction of the center of the galaxy in Sagittarius. This one is kind of not very well calibrated. Another issue I think is causing me issues with calibration is just the ambient air temperature. In a parking lot after a long sunny day, the ground is very warm, and I think it can take a little time for that to cool off. I haven't tried doing any observations at night yet. I really like the fact that you can do stuff in the daytime. And then this is from a couple of weeks ago in the direction of Vulpecula. And so this one I was excited about because I actually got 2 peaks. The main one, and then there's a second one there. So I'm actually seeing pieces of 2 spiral arms. So far, I've just been using the software that comes from Despira. There are two flavors of that. There's the one that was developed by the high school teachers, and that's what I'm using. And then there's one, I guess you call it the aficionados software, which is a more complicated thing. I've had trouble getting that working on my version of Linux, though. I've had some contact with the author, and I can run it now off of a thumb drive. I haven't tried really using any of the backends because what I kept running into is people wanted to do the observation with their front ends, and all the front ends seems to be written for RTL SDR and not for AirSpy. So I'm kind of trying to get my my Python skills back together so I can try to tweak some of these programs for the AirSpy. And let's see if I can figure out how to stop sharing here. Oh, here we go. Okay. And I would like to thank Ted Klein. He very kindly sent me a copy of the backend for the Despira data, and I'm very eager to try that out this week and see if I can suck the data into the Despira system and use some of those graphs. And that's all I've got.
You're pointing to different constellations. How is it you're doing that? Do you look it up and then use its coordinates and eventually get to azimuth and elevation, or what?
Okay, what I do is I use the Stellarium program, kind of simulate what the sky is going to be looking like at different times. And I use that to pick my directions. And then once I'm at the observation place, the parking lot or the city park, I set the azimuth by using a compass, okay? And then for the declination, I found an inclinometer for $5 at Harbor Freight that actually works quite nicely. And I use that to set the angle that I'm observing at. So that's how I've been doing those.
A nice solution. The Linux, I was using Ubuntu 20. What number were you using?
Oh, I'm on Linux Mint, which I have been using for several years, and I'm up to like 22.01 or something.
Okay,
I'm not
good. We have another alternative then. Thanks.
Okay. Yeah, and I'm not that concerned about it. The software runs very nicely off the thumb drive with the older Ubuntu version, so I'll just use that when I'm trying to do some of the other ones.
Okay, Chet, great work.
Thank you.
I have a
Alex, you got anything?
I have a quick question that relates to your.
Go Harris.
Have you tried using a Peltier cooler to cool your radio to keep it sort of stable rather than let it wander off and heat up?
No, I haven't. I've considered putting some thermal sinks on them, on that and on the Sawbird. But I haven't tried doing a Peltier. I also have been looking a little bit at Ted's stuff on calibration with a load, and I have some interest in pursuing that. But I haven't. The temperatures are improving here pretty significantly now, so I think through the fall and until maybe next June or something, I'll be in pretty good shape.
We get that temperature drift over a long period of time. How long are you actually taking a measurement?
Okay, at this point, those graphs I showed you, those were 60 seconds. So it's a short amount of time. And I'm planning to jack it up to like 5 minutes and see what kind of difference that made. Oh, that reminds me, I had a question for you guys. The people there are a bunch of people now that are doing astrophotography on their phones, and they're getting surprisingly good results because they take these exposures and then stack them to get I'll bring out all these little details. Is it possible to stack these radio things? Like, could I take 3 5-minute integrations in a row and then just kind of glom them together? Would that help improve resolution?
Not unless you have a tracking mount.
Oh yeah, that's right.
Well, I do it with drip scanning, but what I do is I stack. I'm looking at. I'm basically tracking. I'm doing extra galactic sources, but
Right.
I'm using drip scanning and not tracking. And what I do is I measure the half power beam width of my dish, so I know how long the transit of whatever I'm looking is going to be. And then what I do is I may take multiple days worth of data, but I use Stellarium as my guide, and I actually use the phone app, and I basically zoom in until the width of the display screen shows field of view equal to my half power beam width, and then I click the times until I find my start and stop transit times, and then that's how and then I just basically make sure that and then I average together all the spectra snapshots when it's in the transit.
Yeah.
And then I'll do that from day to day. And then there's some correction that has to be done to flatten the background because it moves around and morphs a little bit. But
when I did that observation of Vulpecula, I was moving it. I was changing the azimuth 5 degrees every 10 minutes or something. I had done some calculation that showed that I was, and then making an appropriate tweak on the declination to try to keep it centered. But like I said, I haven't tried to analyze the data yet.
Comment on the AirSpy receiver. I've got an AirSpy Mini, and it drifted around a whole lot. I bolted it down to a large heatsink with some heatsink compound, a little bracket to hold it in place, and the stability became far better. So that may be worthwhile. I don't know how the regular AirSpy compares with the Mini, but definitely had thermal problems until I did that. It looks like somebody else has a heatsink there too.
Sure. One of the things I've got going for me is I'm using a cord that's about 12 feet long, and the AirSpy actually sits in the trunk of my car, so it's not in the direct sunlight. The Sawbird is, but the AirSpy is a little bit away from that. So I think that helps some. But I am definitely going to put on some thermal stuff and see if it'll make it more consistent.
What happens with the AirSpy is the spectrum response changes. It's not good, but you probably need to have a longer average to clear up some of the noise to get a more stable spectrum. But I don't think you should ever run the AirSpy without it being on at least some kind of a heat sink, because it gets hot. You need to have it on a piece of aluminum or on a heat sink at a minimum.
Yeah. Well, I'll definitely follow through and do that. Thank you.
You speak of stacking optical images, and I have the advantage that I can put my antenna out there for months and just let the Earth rotate. And sure enough, Ezra will stack it, but from day to day, because that's when it came back to that location. So
sure,
many options are available.
Okay, good.
Yeah, hi, it's Andy again here. So Ezra also has an option in terms of calibration to, rather than calibrating against a load, it takes your same aerial and radio setup and just changes the frequency by however much you want. So we normally do it by 3 megahertz, and it'll do that every other sample. So you don't need to switch anything in and out. It'll just, so on mine, I got 1420, then it goes 1423, then 1420. And so it calibrates literally every sample against the next one.
That's a really really nice idea. I'll have to look into the code some more and
now I want to be clear on that. It's really not calibration. I don't know the precise value of the energy coming in. I just know the relative value. So I call it a reference, not a calibration.
Sure. Yeah, that makes
to
sense.
make that clear. I'm working on calibration though.
Okay.
Okay, I'm going to move on, get some more people in. Alex, you got anything?
Very brief. I do want to show you what a temperature stabilized SDR Mini looks like. This is a, let's see, right there. I took that a couple minutes ago. I'm running a drift scan on a new system, but if you exclude that little rise to the very left, which is an issue associated with either using a 50 ohm calibration resistor and then going to the patch feed on the antenna, the rest of it is a flat line. And I did the initial background calibration when it was about 80 degrees outside, and now it's up to 92. And I guarantee you that the higher end frequencies would be up or down about 3 dB, and that lower end would have shifted. So I have succeeded. That's a very sophisticated system that uses it's a thermal package, little enclosure for the SDR, and it uses temperature controlled thermoelectric coolers, and so it maintains stabilization. But the other one that I do want to show you, let's see. Well, I thought, yeah, hold on. Sort of an introduction into what hopefully we'll see. And Jameson and I have been working on this, and I have completely rebuilt my circular patch feed disc Yagi into a format that can be built with hand tools, electric drill, but the rest can be shears, small saws, and it's designed to be able to be built by, say, a high school student as a science project. So, in fact, that's what I'm running drift scan on right now. And so this H-Line 3D project consists of the explanation of how to use this hardware, how to assemble it, and then Jameson has implemented some of the drift and normalization software into a JavaScript, so that between these two packages, we will wind up with a really impressive system. The software that creates the 3D graphics is spectacular. I've not seen anything like it. So if maybe another month, we'll put together a presentation on this pair of systems. That's all I'm going to say. Jameson might want to add something, but we're still getting the final touches done on that.
I'll just make one minor correction. I'm writing the code in Java. JavaScript is used for web stuff, totally different. I don't even know why they have similar names, but I'm writing this code in Java because I just want to make it portable. It's kind of rough, but next month we should have something to present. But I was happy to get results that match Alex's original MATLAB code. So it looks like the corrections are correct.
Okay, great. Good job, guys. This will be a fun project to keep track of. Let's go.
On the name up on GitHub, there is something called H-Line software. So I don't know if you want to avoid confusion.
Okay. Well, let's go to a time zone challenged person, Robert Lucas in Australia.
Still here. Basically, for me, what I've done is, I've been busy doing other things. So a couple of months ago, I started the scope in a box, running, and just left it running while I went off and did other things. And recently, I stopped to, start to analyze some of the data and, sent some of the, first processes to Ted. And he came back and he said, well, I've been using an old version of Easy Call and a whole bunch of other things. And so I get to, take that and make a new plan and change everything, and then restart it. But I'm also working on my tracking antenna. And what happened is the guy that does the machining for me has gone off for 2 months on a road trip around Australia. And when he gets back, I'll restart that project, type of thing. So we're gaining on it, but for me, I always enjoy doing most of the hardware as opposed to the end result. Okay, so for me, I have an understanding of NMR machines and X-ray diffractometers and stuff like that, and I know the hardware, but putting the end product and pumping something out, it's just it's a learning exercise. So for me, nothing this month, but possibly in a couple months, something new. I mean, okay, off you go.
Okay,
That
thanks.
data from long ago is still useful. Don't toss it.
Oh no, it's stuck in the the NAS. It's up in storage.
Okay, great. Wolfgang just popped in. Wolfgang, what do you got going on?
Yeah, sorry for coming in late. Was quite busy today, so I only could join right now. There's not really much new in the sense of what we're doing. At the SARA conference, I reported about a fast radio burst that we had observed, repeat fast radio burst, and we had the first burst just somehow, fortunately, just a couple of hours before the conference, and we had another burst in between. So that's really the main thing that we're doing from the observational side of things, looking at that fast radio burst. It's a source that only comes above the horizon for us at, first of all, a somewhat inconvenient time at the moment. It's around midnight and extending all the way through 2 o'clock in the night or in the very early morning. And we can only observe it for about 4 hours a day. So we're working on that. We had altogether, we now have 4 events on that source. So we are continuing to work on that. Other than that, actually, I was today at the telescope doing some really sort of nitty-gritty stuff, working around with cables and so on. We did a reconfiguration of our interferometer today, just a different configuration to do some observation in the next couple of days. And I guess that sort of summarizes what we have been doing over the last couple of days or so.
Okay. All right, thanks very much. Let's see. I'm just going to go down the list. Eugene and Igor. You guys on? Okay, hit Jameson. Harris. Harris, you on? Okay. I got Mark H.
Yeah, this is the first time joining the group, and I thought about joining this group probably for about 8 years, maybe 10 years, and I finally have time to start doing this. So I'm looking forward to eventually presenting some material or things that I'm working on, but it's just the beginning stages.
Great. Have you looked at the YouTube channel yet?
I have. Oh yeah, I've definitely looked at that, and there's a lot of things to talk about, but probably not a lot of details to share yet. But I do have a 12-foot dish that I was able to pick up for $100, and honestly, it works. I haven't got it all together yet, but I think it's going to be a perfect antenna to start with, as long as the neighbors don't complain too much.
All right. Well, feel free to come on anytime.
Okay.
All right. Preston.
Okay. I just wanted to thank Jay and everybody involved with the conference. It was quite a great conference. I really did enjoy it, and got a lot of good information, and it was good seeing everybody. That's about all I have this time.
Okay, thanks, Preston.
You're welcome.
A new board member, Don Latham.
What?
What? Are you there?
Oh yeah, this calls for direct confrontation. What on earth are you talking about, board member?
Oh, you were voted in as a board member. Did you realize that? I thought you volunteered.
No,
Oh,
nobody
never mind.
told me.
Okay.
That's fine. I don't mind.
All right.
I'll be bored whether I'm a member or not. It doesn't matter. Thank you. Whoever did that, thanks a lot. Okay, be very happy to. Radio wise, not much to report at this point. Still piddling around. Gonna start characterizing some of these very cheap wideband amplifiers. They're running about 20 dB and they're supposed to be good up to about 6 gigahertz. I think they're lying, but we'll find out. But they're only like $3 a piece or something. So you can buy 10 of them. And if you've got anything to measure them with at all, you can probably pick a couple that'll do yeoman duty. So hopefully I can get that done pretty quick.
Okay. Thanks, Don.
Yep.
Marcus Fisher, our brand new VP and Eastern Conference Coordinator. Also, he is starting a new section in the journal called The Bite. You want to go over that, Marcus?
Yeah, no, just thought maybe have a dedicated software section to the journal. And so this first one is nothing. That's basically just a teaser to try to get folks thinking down those lines of if they have any software interests for articles, topics, whether they want to write them or they just want it written about to speak out. And we'll see what we can do. But just to have a dedicated software section in the journal. And then the second thing I'll bring up for those at the conference, which that was my first one, so I thought it was awesome. But we did for the folks that attended the 40-foot training on the first day, I kept the printout, what the plotter gave us. And I started, Steve was generous to give me the 2015 article that him and his group had wrote regarding their 40-foot observations. So basically, taking the data off the plotter and actually trying to put some meaning towards it. If anybody that was at that training, I have the printout. I'm going to convert it to electronic format and probably write up an article. So if anybody that was there and wants to do that, reach out to me and we'll do that together. Okay. So just FYI on that. Other than that, that's all I had, unless there was any questions.
Okay. Thanks, Marcus. Dennis.
Yes, sir. Pleasure to be here. Thank you very much. I hope everybody's doing well. I really have nothing to report. I want to add my congratulations for a wonderful conference. Everything was incredible. So have a good day.
Okay, I'm going to have to do. There's two Dennises. Thanks, Dennis. Dennis is our past president and treasurer, by the way, and was one of the main instigators for starting the scope in the box system. So congratulate him on that. Okay, Dennis.
And another new board member.
Yeah. Oh, that's right. He just a new board member too. All right. Dennis Hoofnagel.
Okay, thank you. I attended the conference virtually, and you guys did a great job. I really enjoyed that. Of course, the last lecture was the real highlight. And in fact, I took advantage of the discount from whatever they have, the tapes, and got those. So I'm going to be watching that and be able to get a little more insight into that antenna you guys went and looked at. I've gathered some of the scope in a box materials, Just haven't had time to put it all together. Thinking about that today. So anyway, thank you guys very much. This is a very stimulating and exciting, interesting venue here. I like joining you guys. Thanks a lot.
Okay, thanks, Dennis. Nils Holmes. I may have just lost him. Okay, Bruce.
Yes. Hello, I'm here. Just barely driving back from Green Bank area. Tropical storm Debbie was going right through where my house is, and I got like 20 centimeters of rain in a day, and it found leaks in the roof of the house and made a mess of one bathroom, and found leaks in the roof of my workshop that I didn't know were there. So I've had a bunch of electronic equipment I've been drying out over the last few days, and did learn something very interesting. A DMM that I bought, can't remember the brand, couple $100 handheld DMM. But anyway, it was looked like it was thoroughly soaked and no water got inside of it. And I found out where the switch shaft went in, it wasn't a normal switch at all. It's something where it actually rotated a magnet over top of a lot of magnetic Hall sensors inside to switch ranges. So there were basically no holes in the case. It was totally sealed. So it was, about underwater and came out of it with no damage at all, which was, good. And like I said, I learned how the DMM was put together from taking it apart, expecting to dump out a quart of water or something. And so that turned out pretty good. But boy, the water damage, I'm still kind of recovering from that. And by the way, I did notice that Jason and his wife are here today, and I very much appreciated sitting and chatting with them in the Drake's Lounge at the conference. Very pleasant people there. That's about it from here.
Okay, thanks, Bruce.
Just a quick correction. Lisa's my girlfriend. We're not married, but anyway.
Okay.
But yeah, it was so nice meeting everybody. It's just great to actually have personal, firsthand, face-to-face experience meeting some of you guys. So that was great.
All right, great.
And I also wanted to say that the conference was just incredible. I absolutely loved it. I just joined SARA myself, as a matter of fact, and Jason's been sharing, a lot of what he's been doing, and I've been learning a lot with him. Really look forward to learning a lot from this group and learning more about radio astronomy and maybe doing some of my own projects too.
And we all learned more about Scottish culture than we ever thought we would since you two showed up. So thank you for that too. Bob.
Yeah, hello everybody. I spending my time lately on Cosmos watch sensors and got those starting to function and collect data. Now I've got to modify the code so that it'll data log the data, mostly catching muons from the sun. And I also worked on a Python program for my magnetic sensing package and got that up and distributed. This is for the Tapper magnetometer that you can get a hold of for about $100. And that's where I've been spending my time recently. And back to you. That's all I got.
Okay, thanks, Bob. And thank you very much for your service as a board member. He's an off-going board member, and he did great help the whole time. Jay Wilson.
Well, hello. It's good to see everybody here today. And I thank Preston especially for your kind comments about the conference. Really do appreciate that. It was good to see so many of you there. I guess I just have one quick question. We had a drop-in from National Science Foundation, Glenn Langston, who lives in Green Bank, and he was invited by a couple of our members to come to our field exercise one evening. He brought some really interesting horn antennas, and he commented in passing that he has a method of counting muons using a regular 1420 or hydrogen line horn. I had never thought of that before. For a couple of years, Ted Klein and I have been working with high school STEM students on muon surveys using scintillating plastic. So scintillators with photomultiplier tubes. And I was wondering if anybody here has ever used their 21 centimeter system for muon detection. It's about all I've got.
It seems like the muons would just pass right through the sidewalls of the horn, so I'm not sure how that would work myself.
I don't.
How would you?
Yeah,
How would you know it
understand.
worked?
My
I don't
guess
understand
is,
this. How's this going to go?
yeah, my guess is that its interaction with any of the charged particles in the path might be generating very low level signals, broad spectrum signals, because it the way I would think the way that you would discriminate between that and something else would be similar to how you discriminate or how you discriminate with the optical signal, which is it's a super narrow pulse in time. It's like nanoseconds, right? It's very, very short. So.
Okay, thanks. Well, if anybody comes across anything, please let me know. Otherwise, I've written Dr. Langston and asked him to elaborate a bit more. And I'll share that if he comes up with a secret plan.
Okay.
Interesting.
Also, I'm posting in chat information on how to get Dr. Lockman's course on radio astronomy at a professor discount price. So anybody who's interested in that, this will be good for maybe another 2 weeks. So instructions will be in chat. That's all. Goodbye, everybody.
All right. Thanks, Jay, and great work on the conference. All right, Tom Jacobs. You there, Tom?
Greetings, greetings to everyone. I hope this is I'm both visible and audible. But
yep.
Anyhow, using a somewhat different setup for Zoom this time, first time. Let's see. I have things to report. First off, I want to say thank you to the people who made the Eastern Conference very successful. I thought it was very good. And like Bruce, I had to drive through some nasty Debbie rainstorms as my way back here. But the good news is that I suffered no damage here. And other than the fact that I got a lot of rain, there's really nothing else to say about it. And it wasn't a vast amount of rain. It was probably 6 or 8 inches over 48 hours or something like that. And I have seen 30 inches in 24 hours once, and that was a very bad rainstorm. And I think her name was Fran. It's always the women that blow in town that cause trouble. Okay, next thing. The donation to the Green Bank STEM work is in the mail, and they should have it by Friday of next week if the post office is running to their basic standards. Otherwise, it might be the end of the month before they get it. But that check is in the mail along with the cover letter. And I don't know what else to say about that right now, except that we've done it. We still have, we haven't finished paying for the Eastern Conference. So we have a lot of charges that are outgoing that have not yet been paid, but we'll see about it in the near future. That's it. I guess I should also say that, and I did avail myself of the Great Courses Radio Astronomy, and according to the post office, the DVD is waiting for me in my post office. It arrived yesterday evening, according to them, and I will go back probably on Monday to pick that up. Let's see, anything else? Well, I guess I'll ask if anybody has questions. Well, I don't
Okay.
hear anything.
Thanks, Tom. And we're also, if you guys haven't renewed for 2025, do that on the website, on the store. And that's about it. Okay.
Oh, yeah, I will add one last thing. Sometime between now and the end of the month, I'm hoping to get out an email to those people who have not renewed and who are in, who are in the process of losing their membership. And the good news is up until the 1st of August or so, there was a steady trickle of renewals, and that will probably be taken care of very shortly. So anyhow, those people who have renewed, thank you. I'm processing them as they occur, and and pretty soon we're going to we'll be cutting off the people who haven't renewed, whose membership expired in June. So that's the last thing from the treasurer. That will be happening soon.
Okay. Thanks, Tom. Great work. Did I miss anybody? One technical note about the conference. You'll notice that the not all of the conference videos are up. We did. Green Bank lost the afternoon sessions on Monday and Tuesday of the videos, so we do not have those recordings. So if you did do a presentation and they're not up on YouTube now, if you want to redo that, just on a separate YouTube, call me and or let me know, and we'll just have you redo the presentation offline, and then we'll get it posted. Sorry about that. It's just a glitch at the Zoom feature at the Green Bank, so we lost half the afternoon sessions on Monday and Tuesday. Okay, I think that's it. Anybody else have anything? All right, and
Dennis, I have one question. Was there a hard copy printout of the I'm not sure what it's called of the conference?
The proceedings, yeah. Well, no, not a hard copy, but we do have the. Everybody should have gotten a PDF of it.
Oh, okay. Well, a PDF, you mean on a thumb drive or what?
No, just by email. Jay,
okay.
You're going to put out a new one, right, Jay?
Yes, we've received some updates to presentations, and this weekend I'm in the process of updating that. Everybody was registered for the conference already should have received a link to the draft, and this coming week you'll receive a link to the final version. It will be a PDF online, and it will include a PDF of the 40-foot operations manual.
Very good. Well, the only reason I was asking is because up until the world changed in 2020, we had put a hard copy of every proceedings that we had in the library in the Drake Lounge, but it appears those days are gone. And unfortunately, I feel like a dinosaur, but hard copy is kind of like dial telephones, I guess.
Well, actually, we could do that. That'd be a good idea. I didn't even think of that. So yeah, we can go update that with all the proceedings. So next time someone's over at the Drake's Lounge, let us know which proceedings are missing, and we'll get you some hard copies. That sounds like a great idea. Okay, that's all we got. This Friday, U.S. time, but Monday morning, or excuse me, Saturday morning, 9 a.m. Melbourne time is Drake's Lounge Australia. So this Saturday, Drake's Lounge Australia, Melbourne time. And I'll send out a notice here in the next couple of days. That's all we got. Thank you very much. And special thanks to the our Philippine team. They did an outstanding job. You guys all should get A's. Tell that to your professor. This is Professor Russell says, I think it's an A project, and feel free to come back. Okay, that's all we got. Thank you.
Thanks.
Thank you,
Goodbye.
everyone. Thank you, everyone.
Bye.